we have a resistor and then capacitor in series with that, and one more resistance and one more capacitor inductor here. So this capacitive reactance is given as R, and resistance R, inductive reactance is given as R here. Now here I am keeping some AC source. Now the question is, they're asking us power factor. Okay, so what is the power factor for the given circuit? So first of all, you need to understand what is a power factor. So power factor means, okay, the angle between or like phase difference between source, let me write like this, source voltage and source current. So power factor angle, okay, so power factor angle, PF angle is nothing but what? It's nothing but phase difference between source voltage and source current. Sir, how we are going to find that? So we are going to find that from the impedance. Okay, so impedance is the one which will create that phase difference. So why? Because let's say, so in general, in normal current electricity, we know V is nothing but IR, right? Simply. So in here in this chapter, alternating current, we are going to write V equal to I into Z. So let's say if you want, so already I told you these things in this chapter, we are going to treat this like an complex numbers. So complex numbers means, tell me like how it will be written? Magnitude multiplied by, so it can be, complex numbers can be written in two different ways, right? What is the two different ways? Let's say some complex number X can be written as real part plus imaginary part. This is one way of writing it. And another way of writing the same complex number is what? Argument form I can write, no? So how's our argument form? C equal to e power of I into theta, right? Some constant into like e power of I theta. So this is how I can write two different ways of writing a complex number. Now we know that the angle of V will differ from angle of I when there is there is some angle for like what? Z. So let's say I'm writing like this. V is equal to, let's say I is written as I naught magnitude into e power of I theta 1, and Z is written as Z naught into e power of I theta 2. So the angle, okay, the angle of like this one. So now V magnitude can be written as what? I naught Z naught, just like complex numbers. E power of I of theta 1 plus theta 2. Now if I ask what is the angle or argument of V, what will you tell? Theta 1 plus theta 2. Magnitude is what? I naught into Z naught, that is magnitude of both current and like impedance. Now you can clearly see that the phase difference, if I ask what is the phase of current, if I ask argument or phase of current, just theta 1. And what is a phase for voltage? If I ask phase for the voltage or argument of that, what are you going to tell? Theta 1 plus theta 2. Then what's the phase difference? Delta phi. Power factor angle or phase difference between those two, source current, source voltage and source current, is what? Difference of this, which is nothing but theta 2. But what is theta 2 here? Theta 2 is nothing but, okay, the phase or the like argument for like what's up? Impedance. So that's what I told you. The power factor angle is completely depends on what? Power factor angle completely depends on our impedance Z. Okay. And sir, what is general form of writing impedance? General form of writing impedance, Z equal to R plus, okay, J into J or I, whatever is comfortable for you, you can write that. J into XL minus XC. So this is how you're going to write impedance. Now, when three things are in series, keep that in mind. Okay. So we are going to write in this way. Okay. So when we are going to write in this way, when okay, all these points are very, very important. RLC are in series. Then we are going to write this. Okay. So now see, now here these two things are in series, these two things are in series. So let me write this as impedance 1 and let me write this as impedance 2. So Z1 is equal to what, sir? Simply you want to tell R plus J into XL is 0. Okay. So therefore R plus J minus XC, and Z2 equal to R plus J into XL. So J into, so XC is R only, right? Let me write as J minus R plus R. So this is R minus JR. This is R plus JR. So this is R plus JR. So now these two impedances, how they are connected? These two impedances are connected in parallel. So just like resistors, okay, when two resistors are connected in parallel, what is the R equivalent you are going to write? R1 R2 by R1 plus R2, or 1 by R equal to 1 by R1 plus 1 by R2. Similarly here also Z equivalent is nothing but Z1 Z2 by Z1 plus Z2. So here A plus B into A minus B, A square minus B square you are going to get. Then you are going to get R square plus R square, because J square equal to what? Minus 1. But you get 2R. So what is the answer, sir? R. So Z equivalent, simply you're going to get, you're getting a real number. So if you're getting a real number, simply, okay, then what is that power factor angle, sir? Power factor angle also you can write this way, okay. So power factor angle is written as simply tan phi equal to imaginary part, okay, where phi is that angle, okay. Tan phi is written as, actually when it is this form, from here I am writing, from here tan phi is written as XL minus XC by R. So that implies from here also I can write cos theta is nothing but what? Sorry, cos phi. So let me write cos tan theta. Cos theta is nothing but R by under root of this square plus this square. So which is nothing but impedance magnitude. So this is what our power factor. Here theta is PF angle, and cos of PF angle is what, sir? Cos of power factor angle is nothing but our power factor, which is simply given as R by Z. So yeah, so here R and Z both are same, R by R. So cos theta is 1, which means theta equal to 0 degrees. So our power factor angle is how much? Power factor angle is 0 degrees and power factor equal to 1. So everyone understood this? How to treat like these things in the form of like complex numbers?
Yes, sir.
So would you repeat how the last step tan theta is equals to XL minus XC?
So actually, theta is like, see, let's say if I have a complex number again, tan theta equal to A plus IB, I have some complex number, okay? So complex number I have, how to represent that complex number in that complex plane? How much length will be there on x-axis along real axis? A length will be there. And on y-axis, how much length will be there? On imaginary axis, B length will be there. So resultant of these two, just like triangle law of addition, it will be something like this, right? This is our resultant. Now this length is B. So now if I want this angle, the angle made with the x-axis. So tan theta is nothing but what? Opposite side by hypotenuse, which is B by A. So now in place of B, what is there here? XL minus XC. In place of A, what is there? So angle made with respect to x-axis or our real axis, okay, which is nothing but along our real axis only, what will lie? Here in this case A, and here it is nothing but resistance. Understood? How we got tan phi equal to XL minus XC by
Yes,
R.
sir.
So from there you guys know how to find sin cos theta and sin theta. Clear?
Yes, sir.
And here some more important things that you need to keep in mind, okay. Sometimes they're going to tell, uh, they'll give some random circuit and they'll ask the condition for maximum power to be delivered. What's the condition? Can you guys tell? They'll ask condition for maximum power to be delivered. What do you need to do? So based on this, no, like one of the recent previous year IITs, no, they have given a good question based on this. Like, what is the thing that you need to take to ensure this maximum power to be delivered?
Z is equal to R.
Z equal to
R.
so Z equal to R means, yeah, impedance should be purely real. Purely real. If you can get that, so that is the condition you have to take. They give some random circuit in which one of the things is like unknown, and you need to find the Z equivalent of the system, and it should be purely real. So why that case? Why? Because average power formula already we know. What is average power formula? VRMS into IRMS into cos phi. So there is nothing that you can do with VRMS and IRMS. These are like fixed values based on the magnitudes of like peak values of voltage and current. But which one can change, sir? This cos phi, okay, which is our power factor, where phi is the power factor angle. What is the maximum value of cos phi value? Maximum value of cos phi is 1. Maximum value of cos phi is 1. And sir, when you're going to get that maximum value as 1 means when power factor angle is 0, and power factor angle is 0 only for real numbers. So that is only possible when equivalent impedance, equivalent thing is what, sir? Equivalent is only purely real. That means Z equivalent you're going to get in terms of simply R. Okay. So I hope this is clear. Now, if you understood this, I'll give one question. Everyone, ensure that try solving in form of like complex numbers only. So this is how the question is. Second. Okay. So try this question. So, and that maximum power delivering condition only is called as what, sir? What condition is called? That is called as resonance condition. Resonance condition, you can remember the following things in mind. You can keep the following things in mind. What are the following things? Resonance, power factor angle equal to what? PF angle is what? Just now we told 0, and power factor is 1, and also in other words I can tell maximum power is delivered. Okay, maximum power is delivered. In other words also we can tell impedance is Z equivalent is what, sir? Purely real. So any of these things is like valid, then we can tell that that is what condition, sir? Resonance condition. And at resonance, what is going to happen, sir? Maximum power is going to be delivered. In other words, we can tell V comma I will be in same phase. Voltage and current will be in same phase. All the point means the same things only, but you need to remember. Okay, so this is how I can play with the things. So when V and I will be in same phase only, you know that power factor angle will be 0, right? Because power factor angle is nothing but phase difference between the like phase of voltage and current. So when both are in same phase, then only phase difference between those two will be 0. That is our power factor angle. So cos of power factor angle is nothing but power factor. So as power factor is 1, maximum power is delivered in the circuit. That is average power. And this, so in other words, power factor angle can also become 0, like can tell 0 when equivalent impedance is what, sir? Purely real. Purely real. So now I am giving one question. Everyone try solving this. So this is the question. So the question is, so actually, and one more thing, keep this in mind. Okay, in the questions they'll tell voltage is 50 voltage. Okay, voltage is 50 volts and current is 5 ampere. So when they tell like this in alternating, okay, like wherever there's a question based on alternating current. So remember all these things are what values? All these things are RMS values. Unless they mention peak voltage is 50 volt, peak current is 5 amperes. So these things are like what, sir? These things are RMS values. So you need to keep that in mind. Okay, unless they specify peak voltage is 50, peak current is 5 ampere, always you need to ensure that taking these things as RMS only. Okay, so here let's say they have given a question this way. Here there is a switch, 10 to 2 ohm, 8 ohm, 8 ohm, 8 ohm, and here also 8 ohm. And here there is a source. Actually, this source voltage is given as 80 root 2. So source voltage is given as 80 root 2. Now they're telling the total current is I, in this one I1, in this one I2, in this one I3. Now the question is, if the switch is opened, okay, if the switch is opened, what are I1, I2, like what are I1, I2, I3? When the switch is closed, what are I1, I2, I3? Do it.
Sir,
Yeah.
is it 80 root 2 a RMS value or peak value?
That's what I told. No, if they're not mentioning anything, if they're just giving like this, what is this value? This is how they gave in the diagram. Okay, I am not like writing in shortcuts. This is how they have given in the diagram. That means what you need to understand. This is what value?
RMS.
RMS. If nothing is mentioned, remember it is always RMS value. Otherwise, they'll clearly mention the peak value. Okay, is this much? Done. Two questions I asked before the switch is open, before the switch is closed, and after the switch is closed. Anyone has got? At least before the switch is closed. See, just like complex numbers, that's what I told you. If you understand like how to convert this thing into complex numbers, no. So literally, you'll play with this alternating current chapter. You just need to know how to convert this. See, let's say I want to know I1 value. Okay, so let me find I1 value. I1 value can I write? See, across this only this voltage source is there. So can I write like simply like Vs by Z1? Yes, sir. We can write simply Vs by Z1. So here as nothing as mentioned. Okay. So for time being, let me take this angle as 0 degrees. Okay. So first let me find magnitude. Then I'll later bother about angles. So Vs. So remember here if I take peak values, if I want I peak value, I'll take peak value of source voltage, peak value of like the magnitude of Z1. If I want RMS, I'll take RMS. If I want complete value, I'll take complete value of I and complete value of Vs. I just want RMS value of I1. So Vs RMS is 80 root 2. And Z1, what is Z1, sir? Z1 can be written as complex number by like how? Z1 equal to 8 plus J8. And this one can be written as Z2 can be written as what? Z2 can be written as 8 minus J8. That's it. So if I want magnitude of Z1, what is magnitude of Z1 from here? 8 root 2. Right? Complex number magnitude is what? 8 root 2. So done. I1 is how much, sir? I1 is 10 amperes. Similarly, I2 is how much? I2 is also Vs by Z2 only. Vs by Z2 means again 80 root 2 by 8 root 2. So answer is what, sir? Again 10 amps. But what's the difference between these two? Can you guys tell anyone? Can anyone tell me what is
Phase
the
difference.
there will be a phase difference. Whatever I have found, these are like RMS values only. These are RMS values. Okay. If I want to like know I value, how to get I value? There are two different ways of finding I value. What are the two different ways? Just tell me. Two different ways. One way is I can be written as I1 plus I2. This is one way. But you have to always keep in mind that, sorry, I'll add 10 plus 10. Answer is 20, sir. That is completely wrong. Here the currents are not scalars. Okay. If the current would have been scalars, here the complete alternating current is about dealing with phasors. Phasors are nothing but one kind of vectors only, right? What are phasors? I clearly told, right? One day, what are phasors? What are phasors? No one remember that word? Rotating vectors. Phasors means what's a rotating vectors? They'll have a particular magnitude and direction, and they're going to rotate with an angular frequency. See, let's say if I write I equal to I naught sine omega t plus 30 degrees. This is only called as phasor. Sir, why phasor? It is going to keep on. Tell me this angle keep on changes with respect to time or not? Initially at t equal to 0, what is the angle? 30. After some time it will become 60 angle. After some time it will become 90 degrees. After some time it is going to become 120. That means this vector is going to like keep on rotating, and its magnitude is like what? I naught. Magnitude length of that vector is what, sir? I naught is the length of the vector, and this is the 30 degrees is called as initial phase, and this vector is going to rotate with what angular frequency? Omega angular frequency. So that's why these phasors are nothing but like one kind of vectors only, and you guys know vectors cannot be added simply. So 10 plus, if I know these two are vectors, 10 plus 10, can I write simply 20? Can we write 20? No, right? Because these are not scalars. So like just like same way, remember I1 and I2 are not scalars, so you cannot simply add them. So you need to either like do whatever I told, phasor sum, or else there's another way of solving it like easily. What is the other way? Can you guys tell? The other way is, can I find Z equivalent or not? Because Z1, Z2 I know. Z equivalent if I find, I can find simply total I, because source voltage I know. I want source current only. So Z equivalent I will find. Z equivalent is what? Z1, Z2 by Z1 plus Z2. So what will I get? 8 square plus 8 square by Z1 plus Z2 is what? 2 into 8. Then answer is what, sir? 8 ohm. Z equivalent is 8 ohm. So therefore, I is nothing but Vs by Z equivalent. So Vs is how much? 80 root 2 by Z equivalent is how much? Just now I got 8. So answer is what, sir? 10 root 2. Is that clear?
Yes.
But just to give you more clarity, I want to solve this by this method also, and I want to show you, so that you guys will get more and more clarity that, okay, so basically these currents are what? Phases. So whenever I want to add them, not only like currents, the voltages also, let's say Vs, this Vs, no, this Vs can be written in this way also, plus minus Vr. Okay, so I can write this way, plus minus voltage across resistor plus minus voltage across inductor. So I can write voltage across this is nothing but voltage across this plus voltage across this. That means Vs can be written as Vr plus Vl, but these are not scalar sums. These are again what, sir? Vector sum only. Whatever you have done in simple current electricity, those are scalar sums. And whatever you are going to do here, these are like what, sir? These are like phasor sums. So let me do that by using these phasors, then easily you'll understand. So simply I equal to I1 plus I2. Okay. So if this is RMS value, what is peak value? Can you guys tell? 160, no, into root 2. So that means actually Vs can be written as what, sir? 160 angle reference I'm taking 0 degrees. If that is the case, now I1 if I want to write, Vs 160 angle 0 degrees by Z1. What is Z1? Can you guys tell me here? What is Z1 from here? Magnitude is what? 8 root 2, but angle, you know, tan phi is what? 8 by 8. Tan phi is 1 means what is angle? Angle 45 degrees. So 8 root 2 means how much will be there, sir? 10 root 2. 10 root 2 angle minus 45 degrees. Correct? Understood, no? Everyone understood this step? Similarly, I2. Any doubt is there in this? Hello?
No, sir.
8 root 2. And what is the angle for this one? Now y is minus is there, no? So minus 1, tan phi is minus 1 means minus 45 degrees. So now what will you get? 10 root 2 plus 45 degrees. So what is the phase difference now? See? Now you can clearly see that how much angle difference is there between these two. Two vectors are separated by how much angle?
90.
90. So then you guys know resultant. Resultant vector is like what? Resultant of two vectors. I net or I is nothing but under root I1 square plus I2 square plus 2 root I1 I2 cos delta phi. Phase difference between them is 90. Cos 90 is 0. Simply I under root of I1 square plus I2 square you are going to get. So what is that? Under root of 10 root 2 whole square plus 10 root 2 whole square. So 10 root 2 in 10 root 2 into root 2 is 20. Sir, we got wrong answer, sir. Here we got 20 and actually earlier we got 10 root 2. Is that so? Is the answer what we got wrong?
No, sir.
Why?
This is I naught value, whereas that one is IRMS.
So whatever I have found is, no, these are peak values. Whatever I have written here, actually these are like peak values I am writing here. So 20 I got peak value, but I want RMS value. Peak value to RMS value, how to get that? Divide that by like root 2, then you will get the same answer, 10 root 2. Everyone got the clarity?
Yes, sir.
So I hope everyone understood this. So this is how you need to see the alternating current circuits. See, already you will be doing very very tough questions from complex numbers, and if you can just understand the sense of how to convert this alternating current into, as I said again and again, I'm repeating the same thing because that is the fact. If you're able to convert this into complex numbers, simple complex numbers, so literally you're going to play with this chapter. Okay, because then it's nothing but simply simple current electricity things, whatever you know, and then simple basics of complex numbers, whatever you have learned in maths. So then that's all. So this chapter you can solve. Now I'm giving one question. So try solving this. So there is a circuit like this. Here they're telling there is some box. We don't know what is there in that box. In that they're telling that through this the current that is flowing I2 is given as I naught sine omega t minus pi by 2. This is what they gave. And here there is a resistor, and through which I1, okay, which is RMS current is flowing. Resistance is given as R, and which is connected to a source of voltage V naught sine omega t. So this is what they have given. Now they're telling for the shown AC circuit, power factor of the circuit is root 3 by 2. They gave power factor of the circuit cos phi. Power factor of the complete circuit they gave root 3 by 2. And next they're telling ratio of maximum current in the resistor and the box is, okay, they're telling what is the maximum current. Maximum current here will be like what? First question. First question that they're asking is two questions they're asked. First question they asked ratio of maximum current in the resistor. What is the maximum current in the resistor? RMS is I1 means basically I1 root 2 by I naught they're asking. That's the first question. And second question they're asking is when the impedance of the box is 100, the total impedance of the circuit is, let's say, Z. If Z equal to 100, what is Z equivalent? Solve it.
Sir, that cos phi is for whole circuit or only for
circuit.
box?
No, whole circuit. The power factor of the circuit is root 3 by 2. See, here no, you need to understand like some more things clearly about the basics. See, voltage I know here, sine omega t, and here I know the current. So here if you see, current is lagging voltage by perfectly how much angle? 90 degrees. So when that is possible, for what kind of element that is possible? So if you just remember in the basic,
Inductor.
yeah, that's it. So that means basically you need to understand in box what is there. In box you have like inductance circuit. This is nothing but inductor is there. So if you know that, that is simply done. So Z XL, so Z is equal to what's simply here XL is there. Clear? So now these two are like how they are connected. So these two are like parallel. So Z equivalent, what is the formula? From Z equivalent only you can get the power factor, no? So what is Z equivalent here? Z equivalent is nothing but Z1, Z2. So R into JXL by R1 plus R2, R plus JXL. So you can convert this into like what? Just like normal simple complex number this way. How you can convert that, sir? R minus JXL, and here also R minus JXL. So A plus B into A minus B. So in denominator what will you get? R square plus XL square you are going to get. Fine. R square plus XL square you are going to get. And what else you are going to get? RMS into RMS. And in denominator, numerator what you are going to get? You multiply these two, J square minus J plus 1, R XL square plus R square J XL. So now J R square XL. Let me write J R square XL. So from here, what is tan phi? Tan phi is this one, opposite complex. What I can tell, complex part by real part. What is complex part by real part? R square XL by R XL square. So what you are going to get, sir, here? Simply one numerator R will be left out, R by XL. So if cos phi is R by XL, cos phi is R by XL. Let me check out the question. I think I missed it. Cos phi is, then cos phi is how much from there? Cos phi is how much? Denominator XL by under root of R square plus XL square. So this is given as root 3 by 2. So this is one equation that we got. But in the question, what they're asking, maximum of phi 1 root 2 by I naught. So maximum of this one you need, right? I naught can be written as what? Peak. V naught by Z of this one. Resistance of this one is R. Similarly, sorry, I naught is in the numerator, no? I naught means here. So that means V naught by XL. This is maximum of like what? My bad. 1 second. We need denominator I naught. I naught means where is I naught? Here. So peak of this one. Peak of this one, how to write? Peak of this one can be written as V naught by impedance of that. Impedance of that is what? Just now we have seen impedance of that is XL. And here I1 root 2. I1 root 2 is nothing but peak value of this one. Peak value of that one can be written as what? V naught by R. So what you're going to get, sir, from here? Can you guys tell? What you're going to get from here? XL by R. So what is XL by R? So if cos phi is root 3 by 2, that means theta is what? Theta is 30 degrees. So if theta is 30 degrees, what is tan 30? What is tan 30? 1 by root 3. So R by XL is 1 by root 3 means XL by R is how much? Root 3. Is it clear? Understood what we have done?
Yes.
We got
Sir, will you repeat the question?
repeating what? Question.
Question is.
Question is like we need to find what is this maximum value of current in the resistor to the maximum value of current in the box. That is the question. Maximum value of current in the box is what? Maximum voltage, peak voltage V naught by its impedance. Its impedance is XL. Because it is like what circuit? Inductive circuit. And maximum value of current in resistor is given as what? Maximum voltage V naught. Okay. So already I told you here I1 is RMS. Okay. So if you want maximum value of current, which is I1 root 2. So maximum value of current is nothing but maximum voltage by its impedance. Impedance here is R. So I took the ratio and I got XL by R. But here, like they gave the power factor for the complete circuit. Power factor for, if you remember, I told you can get it from where? Power factor for the complete circuit, you can get it from after writing Z equivalent of the circuit. After writing Z equivalent. So this is what I have tried of writing. Z equivalent when I wrote Z equivalent for these two in parallel. So here you cannot think that sir, simply a resistor and inductor is there. I'll write R plus JXL. No. So when can you write R plus JXL? When those two are in series. But now these two are in parallel. So I have written R1, R2 by R1 plus R2. That is Z1. Z equivalent is Z1, Z2 by Z1 plus Z2. And I converted back into what form? A plus IB form. In denominator, no complex number should be there, no, to convert into general form. And after that, tan phi is nothing but what? Imaginary part by real part. When I did this, I got this. But when power factor is root 3 by 2, that means power factor angle is 30 degrees. When phi is 30 degrees or theta is 30 degrees, then tan 30 is what? 1 by root 3. So R by XL is 1 by root 3. So therefore, we need for finding the ratio, we need XL by R. So XL by R is how much? Inverse reciprocal of this, which is root 3 will be the answer. Clear?
Yes.
Now what about second one? Tell me the answer for second one then.
So
Yeah.
in that Z is equals to 100, so XL is equals to 100, na?
Yeah. So if you have done like first one, no, second one would also be very easy for you. So why Z equal to 100 means XL equal to how much? XL they gave 100. So already from the power factor thing we got. Okay, what we have, sir? XL by R. The above question we got it as root 3. So which implies R equal to XL by root 3, which is 100 by root 3. R is 100 by root 3. XL is this one. So therefore, Z equivalent. Sir, what is Z equivalent now? Z equivalent is What is the value that I got? Actually, I forgot. R XL square plus J into, we need magnitude only, no? Z equivalent total impedance. Let me write it as complex number and solve. Then Z1, wait. I want Z equivalent, right? Is it becoming lengthy? I got R and I got this one. So then Z equivalent is nothing but Z1 Z2 by Z1 plus Z2. So that is 100 root 3 into J of 100 Z1 Z2 by Z1 plus Z2. What is Z1 plus Z2? 100 root 3 plus J into 100. So hundreds will be cancelled. Then what is left out? Z equivalent is nothing but J by root 3 by, oh sorry, only 100 will be cancelled, my bad. By 2 times, because in numerator multiplication is there, no? 100 will be cancelled. If you take 100 outside, J by root 3 by, if I take LCM, 1 plus J root 3 by root 3. So root 3 will be cancelled. So 100 times of J by 1 plus J root 3. So mod of Z1 by Z2 means mod Z1 by mod Z2 we can take, right? Correct, no? So actually you have to find magnitude of this one. Is this property there? Mod of Z1 by Z2 is nothing but what? Mod Z1 by mod Z2. Is it there?
Yes, sir.
Then simply what we can write, if you want to mod of this one, simply by this one, what is the magnitude of this one? 2. So answer is what, sir? 50 ohms is the answer. Clear?
Sir,
Yeah.
I wanted to ask you that one thing. In the last 7-8 days, what should I do for JEE Advanced in physics?
That's what actually I was about to tell in the message, but anyway